Hey, what's up, you guys? This is page 218. So please go and join me in your math book on that page. Now, we're using information from the math book to answer the following question, all right? Consider circle P. It's related to the learning goals at the beginning of this lesson that say use diagonals to draw quadrilaterals. That's what we're doing. Make conjectures about the diagonals of special quadrilaterals, and then make conjectures about the angle relationships of those special quadrilaterals. It would be amazingly helpful if you watched the first two videos from page 217, specifically so you could create this shape. This is QR. This is the perpendicular bisector made with the circles of QR. And then I'm going to transfer that information to this circle using the tracing paper. So if you haven't done that yet, you should go watch the previous two videos from the page 217. There's angle V. Here's angle W. All right? Now I'm going to draw the line that's between them. So I'm going to go from angle V to angle W. And I'm doing this kind of before I even read the question. We're attending to precision. We are critiquing the reasoning of others. Now, we've constructed, well, okay, this is QSRT, so I guess I don't really need VW. All right. I did do this part, though. I constructed the perpendicular bisector of QR through point P. I used the tracing paper to do it. So if you need to see that, don't just freehand it, eyeball it, do it right. Use a compass. Okay. Now, use the patty paper to trace QR, so check. Without moving the patty paper, draw a diameter ST of circle P in such a way that it is not perpendicular or coincident. That's a vocab word I know that we saw. Coincident means to be lined up with. So if I was to use my tracing paper, I'd say, like, look, right now, QR is on top of itself. It's coincident. But if I twist it just a little bit, that makes it not coincident because it doesn't exactly line up, which is what they're saying. Without moving the patty paper, draw diameter ST of circle P in such a way that it is not perpendicular. So all we need to do is just draw a diameter. And they say to do it on the patty paper, but I'm looking at my notes. I'm just going to make it happen actually on the picture. So I'm going to go and draw this. I kind of tilted it through the middle. Maybe it's like cutting a piece of pie. Here is, consulting my notes, S should go up there, and T should go on the bottom. By the way, you do need to have a straight edge, like the edge of a protractor, because if you do this freehand and you have squiggly lines, man, this doesn't mean anything then. All of your work is useless garbage. Use a straight edge so that you have done it right. Okay, we're going to connect QS. If I'm reading right, connect the endpoints of the diameters to draw quadrilateral QSRT. The order matters. So QS, you might even want to consider taking this page out of your book. Then we're going to go SR. Then we're going to go RT. Draw the line segments. Try to be as precise as you can. The more precise you are, the less human error you have, the better your creations will be. Okay, there it is. I got this quadrilateral. It's got four sides. Okay, reminder, by the way, you guys, that PQ is a radius, PR is a radius, PS is a radius, PT is a radius, and they all get 1 spikes because they are all equal. Oh, it's on the word wall. We've talked about it in class. We've talked about it before. It's not this vocabulary word, or the fact that this video is brought to you by the word arc. See it? It's an arc. Okay, arc. It's a part of a circle. Our vocab word is on the word wall. This is about vertical angles. Do you see vertical angles in this picture? I sure do. I see a vertical angle made right there with, on the other side, right there. So SPR as an angle has a matching partner, QPT. And they're congruent because vertical angles are the same size. There is another pair of vertical angles in this quadrilateral. SPQ, that's this angle, and RPT, that's the other side. They're also the same angle. They're different than the ones I highlighted yellow, because those are the small acute angles, but these two angles are obtuse, and they're equal because, or congruent's the better word, they're congruent because they're vertical angles. Two lines that make an X form vertical angles. Okay, what do you know about QR and ST? I mean, they're diagonals. QR and ST are diagonals of circle O. All right? Because they're diagonals of circle O, then that means that PQ is congruent to PS is congruent to PR is congruent to PT. That's what I drew with the spikes all the way around. So spike, 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 and spike. Those are all radii, therefore they are congruent. But PQ and PS, actually let's go PS and PT, the full length of it is a diagonal. PQ, PR, the full length of that is a diagonal. So that means that these diagonals bisect each other. That was true on page 217 with the square, but this is the time to talk about it, that actually squares, rectangles, parallelograms, the diagonals will cross each other, and where they cross creates exactly the middle of that rectangle. P is exactly the middle of the rectangle. You can do this for parallelograms, for squares, maybe for isosceles trapezoids, but not for regular trapezoids or kites, rhombuses, rhombi, I mean. You can put the diagonal, and where they cross is exactly the middle. That's how you know you have a rectangle, a parallelogram styled rectangle. I need to pause the video here. Please carry on with parts B, C, D in the next part. Thanks for watching.